Welcome students. Today I am going to discuss energies of orbitals. So let's start. The energies of various orbitals can be shown by an arrangement, and that arrangement is known as energy level diagram, in which different orbitals arrange according to their energy. That diagram is known as energy level diagram. Now let's start with hydrogen atom. For hydrogen atom, as we know that hydrogen is the atom which has only one electron in its shell. So hydrogen will also be considered as a single electron species. So let's see the energy level, energy orbitals or the energy level diagrams for the orbitals of hydrogen atom. The energy of an electron in an hydrogen atom is determined by principal quantum number n, and it is independent of the value of the azimuthal quantum number L. Energy of an electron for hydrogen atom, it depends upon the principal quantum number n, but it is independent of the value of azimuthal quantum number L. It means all the subshells, because azimuthal quantum number L determines the value of subshell. So for all the subshell S, P, D, F and so on in a given principal shell have the same energy, because for hydrogen atom there is only one electron, and the energy of the hydrogen atom it is independent of the azimuthal quantum number, and we know that azimuthal quantum number denotes the subshell. It gives the knowledge of subshell, and the subshells are S, P, D and F. So for a given particular principal shell, the energies of those subshell will remain same for hydrogen atom. For example, let's see this with an example. Suppose we are in second shell. For second shell, the value of principal quantum number will be equal to 2, and in second shell there will be two subshells, and the two subshells will be S and P subshell. Now S and P two subshells are there, so 2s and 2p will be the orbital for the second shell. Now that this 2s and 2p orbital will have the same energy for hydrogen atom, because there is only one इलेक्ट्रॉन. सो वो जो एक इलेक्ट्रॉन 2s में था वो जम करके 2p में जाएगा. वो 2s एंड 2p उनकी एनर्जी सेम रहेगी. अगर हम बात करते हैं प्रिंसिपल क्वांटम नंबर, अगर हमारा प्रिंसिपल क्वांटम नंबर और द वैल्यू ऑफ m इज सेम, then all the subshells in which are coming in that shell, that will have the same energies for hydrogen atom only, which has only one electron. Now similarly all the orbitals of third shell as well. For third shell the value of n will be equal to 3. So for third shell the subshells will be, for n equal to 3 the subshells will be S, P and D. So the orbitals comes to be 3s, 3p, 3d. They will have the same energy. And similarly for fourth shell, n equal to 4, the subshells will be S, P, D and F, and the orbitals comes to be 4s, 4p, 4d and 4f, and all these four orbitals will have same energy for the same value of principal quantum number n. As I already discussed that for an hydrogen atom the energy does not depend upon azimuthal quantum number L. What will be the value of L in this case? For the same value of principal quantum number, whatever be the value of azimuthal quantum number, the energy will be same for the same principal quantum number of that particular orbital. For 4s and 4p, for hydrogen atom, if we are talking about 4s and 4p, 4s orbital and 4p orbital both will have same energy. Why? Because their principal quantum number value is same. And the orbitals having the same energy are called degenerate orbitals. These orbitals which are having same energy, these are known as degenerate orbitals. Now the order of energy levels, that can be in this order. As we know that energy level increases as the cell number get increases. So the order of energy level, first shell will have the lower energy level, then the second shell, then third shell, and so on up to infinity, up to n equal to infinity. The energy levels increases as the shell number increases, and the shell number depends upon and principal quantum number depends upon shells. So for 1s will lie lower as compared to 2s, and 2s and 2p will have same energy. Then 3s, then third shell will come, and 3s, 3p, 3d, all the orbital which are in third shell, that will have the same energy. And as we come to fourth shell, all the orbitals which are present in fourth shell, that are 4s, 4p, 4d and 4f, they all will have the same energy. This can further be seen by this image also. This 1s has the lower energy level, its energy level is low. Now as we come to 2s, so this 2s will have the more energy, higher energy level as compared to 1s, because cell number is getting increases. But in second shell, there are two subshell S and P, and they are forming two orbital, 2s and 2p orbital. So those both 2s and 2p orbital will have same energy. Similarly for third shell, and similarly for fourth shell, and so on. So this is the energy label diagram for hydrogen atom, in which there is only one electron is present. Now let's see when there are multi electrons are present. When there are more than one electrons are present, now what will happen, and how can you arrange such orbitals in their energy labels? So for multi-electron atom, if our atom has more than one electron, so for such type of atom, now the labels of energy will be different from the hydrogen atom. In this case, the energies of orbitals, the energies will be different, and the energies, if the orbital having the same value of principal quantum number n, but the different value of azimuthal quantum number L, then the energies will be different in this case. अभी हमने हाइड्रोजन एटम का देखा, वहां पे L की वैल्यू डिफरेंट थी. अगर हमारे n की प्रिंसिपल क्वांटम नंबर की वैल्यू सेम है, बट हमारे एज्यूमिथल क्वांटम नंबर की वैल्यू डिफरेंट थी हाइड्रोजन के केस में, बट इन केस ऑफ हाइड्रोजन फिर भी उनका एनर्जी लेवल सेम था. बट इन केस ऑफ मल्टी इलेक्ट्रॉन सिस्टम, जहां पे एक से ज्यादा इलेक्ट्रॉन प्रेजेंट है, इफ such type of atom is there, then in that case, if the value of n is same, अगर वो प्रिंसिपल क्वांटम नंबर की वैल्यू सेम भी है और डिफरेंट L की वैल्यू है, then the value of energy labels will be different for multi-electron atom. And the energies of the orbital depends upon n as well as L in this case. But for hydrogen atom, the energy levels depending upon only on n, not on azimuthal quantum number. But in case of multi-electron atom, the energies of the orbital depends upon the value of principal quantum number as well as the value of azimuthal quantum number L. Also, the different subshell of the same energy have different energy as well. Now for example, for 2s and 2p orbital, for 2s and 2p orbital, the shell number will be 2, because it is for any principal quantum number will be 2 for 2s and 2p orbital, and the subshells are s and p. And so this 2s and 2p orbitals will have different energy for multi electron system. और अभी हमने हाइड्रोजन एटम के लिए देखा, हाइड्रोजन एटम में वो L की वैल्यू पे डिपेंड तो करेगा नहीं एनर्जी, बिकॉज देयर इज ओनली वन इलेक्ट्रॉन. सो द 2s and 2p की जो एनर्जी लेवल्स हैं, इट इज सिमिलर इन केस ऑफ हाइड्रोजन एटम, बट इन केस ऑफ मल्टी इलेक्ट्रॉन सिस्टम इट इज डिफरेंट. 2s and 2p orbital will have different energies, and the main reason having different energy of the subshell is the mutual repulsion among the electrons in a multi-electron atom. Because in a multi-electron atom there are electrons more than one. So when the electrons are more than one, so there will be a mutual repulsion between the electrons of that particular atom. So due to that mutual repulsion, the energy levels will get changes, or there will be a different energy labels for the same value, for the same energy shell, for the same subshell, same energy shell, the different subshell will have the different energy value in that case. Now the cause of different energy patterns of hydrogen atom and multi-electron atoms, it is this energy depends upon the nuclear charge, principal energy level, and the presence of electrons in the lower energy levels. Now in a multi-electron atom, the electrons occupying the inner energy levels tend to reduce the effect of nuclear charge on the electrons present in the outer energy level. Now why there is a difference in the energy levels of the same shell when the azimuthal quantum number is different? Now why there is a difference in the energy levels? This is due to the mutual repulsion of the multi-electron system. Now what will happen if we have a nucleus, if we have a nucleus here, and this is the first shell, and this is second shell, and this is third shell. Now what happens, the inner electrons, the inner energy levels, the shell which are present in front of the nucleus and which are close to the nucleus, they will reduce the effect of the nuclear charge on the electrons which are present in the outermost energy level, or which are present in this outermost energy shell. Now why it is so, why this is so? Because we know that the nucleus is positively charged, because the protons are present in the nucleus, so the nucleus will be positively charged, and the electrons are present in particular shells. Suppose I am talking about shell first, n equal to first, so 2 electrons will be there. In n equal to 1 there will be 2 electrons. Now what happens, these electrons are attracted by the nucleus, as well as there is some mutual interaction or mutual repulsion between these two electrons as well. Now these electrons, as they are close to nucleus, so they will have strong holding with the nucleus. Now as we come to this third shell, where as we come to the electrons of this third shell, n equal to 3, now what will happen, the electrons which are present and n equal to 1, they will reduce the effect of the electrons which are present on n equal to 3 on this third shell. Why this is so? बिकॉज वो इलेक्ट्रॉन्स जो फर्स्ट शेल में प्रेजेंट है वो न्यूक्लियस के ज़्यादा क्लोज है, न्यूक्लियस को उन्होंने हाइड करके रखा हुआ है. अगर हम उसके नेक्स्ट शेल की बात करें, सपोज वी आर टॉकिंग अबाउट n इक्वल टू 2 और n इक्वल टू 3, सो जो n इक्वल टू 2 एंड 3 में जो इलेक्ट्रॉन्स प्रेजेंट होंगे उनको शील्ड कर देगा n इक्वल टू 1 वाला इलेक्ट्रॉन. इफ आई एम टॉकिंग अबाउट n इक्वल टू 1, n इक्वल टू 2 इलेक्ट्रॉन्स, तो n इक्वल टू 2 इलेक्ट्रॉन्स का जो इंटरेक्शन न्यूक्लियस के साथ होगा वो कम होगा एज कम्पेयर टू द इलेक्ट्रॉन्स ऑफ n इक्वल टू 1 शेल. सिमिलरली अगर मैं n इक्वल टू 3 शेल में आऊँ तो उनके इलेक्ट्रॉन n इक्वल टू 3 शेल में जो इलेक्ट्रॉन्स हैं उसके जो इलेक्ट्रॉन्स का इंटरेक्शन है न्यूक्लियस के साथ वो और कम होगा एज कम्पेयर टू n इक्वल टू 2 सेकेंड शेल के इलेक्ट्रॉन से. क्यों? क्योंकि अभी उसके आगे दो ऐसे शेल्स हैं जिन्होंने उसको शील्ड करके रखा, उसे कवर करके रख दिया. ठीक. नाउ द इनर इलेक्ट्रॉन्स शील्ड्स और स्क्रीन द आउटर मोस्ट इलेक्ट्रॉन. The inner electron has a tendency to shield or screen the outermost electron of the shell, and this effect is known as shielding effect or the screening effect. This effect is known as shielding effect or the screening effect as well. And the net positive charge. Now the net positive charge experienced by the electron from the nucleus is called effective nuclear charge. अब जो चार्ज आया, जो आउटर मोस्ट इलेक्ट्रॉन जो न्यूक्लियस के साथ जो चार्ज शेयर कर रहे थे, जो पॉजिटिव चार्ज था, दैट चार्ज इज नॉट द एक्चुअल चार्ज. व्हाई? बिकॉज द इनर इलेक्ट्रॉन शील्डेड द आउटर मोस्ट इलेक्ट्रॉन. तो अब जो चार्ज का जो इफेक्ट होगा वो एक्चुअल तो नहीं होगा, बट जो इफेक्ट होगा दैट चार्ज इज नोन एज इफेक्टिव न्यूक्लियर चार्ज एंड इट इज डिनोटेड बाय ZeFF. Now if we compare with the shape and the size of the orbitals, the shielding effect will be like for s orbital, because we know that s orbital is spherical in shape. So being spherical in shape, s orbital shields the electrons from the nucleus more effectively as compared to the p orbital. S orbital has more tendency to shield the electrons from the nucleus than the p orbital, and due to the difference in their shapes like p orbital and d orbital, p orbital shields the electron from the nucleus more than the d orbital, and so on, and d orbital will shield electrons more from the nucleus than f orbital, and so on. So the effective nuclear charge experienced by the orbital decreases with increase in azimuthal quantum number L. As the value of azimuthal quantum number L increases, so the effective nuclear charge at that case gets decreases. For s orbital, the value of azimuthal quantum number L is equal 0, and for p orbital the value of azimuthal quantum number is equal 1. So the effective nuclear charge will get decreases. For s orbital the effective nuclear charge will be less as the value of for p orbital the value of azimuthal quantum number is larger as compared to the s orbital. So for p orbital the effective nuclear charge will be less एस कंपेयर टू एस ऑर्बिटल, बिकॉज वी नो डेट एस ऑर्बिटल की ज़्यादा टेंडेंसी है जो अपने इलेक्ट्रॉन्स को शील्ड करे, और पी ऑर्बिटल की टेंडेंसी लेस है इलेक्ट्रॉन को शील्ड करने की, तो इफेक्टिव न्यूक्लियर चार्ज भी पी ऑर्बिटल की कंडीशन में कम होगा, डिक्रीज करेगा. द रीजन बिहाइंड दिस बिकॉज उसका जो एजिमुथल क्वांटम नंबर है उसकी वैल्यू इंक्रीज कर रही है एज कंपेयर टू एस ऑर्बिटल. Now s orbital will be more tightly bound to the nucleus than p orbital. Because of smaller size or the spherical size, we know that s orbital is more tightly bound to the nucleus than p orbital, तभी वो shield भी ज़्यादा कर रहा है. While the p orbital will be tightly bound to the nucleus than the d orbital and so on. So thus the energy of different orbital will be increases. Now the energy will be increases in the pattern, and the pattern of energy levels will be s orbital will have lower energy, then p, then d, and then f orbital. This can be seen here in this image also. Here you can see for a multi-electron system, for first shell the energy of s will be less, so for because its screening effect is more, so its energy is less because it is closer, or it energy level is less energy level as compared to other orbital. Why? Because it is very close to the nucleus and its screening effect is more as well. So for 1s orbital the energy level is low. Now as we come to second shell where two orbitals are present, 2s and 2p, because two subshells are there, s and p, so two orbitals are there, and we know that as the value of azimuthal quantum number increases the energy levels also get increases. So for 2s azimuthal quantum number for s is equal 0, it will be have low energy, and for p azimuthal quantum number is l, it will be have higher energy. Now it is more clear from the further explanations. Now the arrangement of orbitals in increasing order of energy on the basis of n plus l rule. Now let's see, the lower the values of n plus l, the lower the value of principal quantum number n plus azimuthal quantum number l for any of the orbital, the lower is its energy. And if two orbitals have the same value of principal quantum number plus azimuthal quantum number, then the orbital with lower value of principal quantum number will have the lower energy. Now let's see. Here in this table, as suppose we have orbital, 1s orbital is there. So for 1s orbital the value of n is 1 and the value of l will be 0, because s is there, s subshell is there, so the value of l will be 0, and the value of n plus l, it is 1 plus 0, it comes to be 1. And we know that at the value, if the value of n plus l is 0, so the energy level is also lower. And for 2s orbital the value of n is 2, the value of l is 0. Now the value of n plus l comes to be 2, and as we compare 1s and 2s, so 1s will have the lower energy as compared to 2s, because n plus 1 for 1s comes to be low as compared to 2s. Now come to 2p, second shell again. These both are example of second shell. N equal to 2, L equal to 1 in this case, because P subshell is there. So for P subshell the value of azimuthal quantum number is 1. So n plus 1 will be 2 plus 1. It comes to be 3. Now as we come to 3s. Now as we compare 2s and 2p, so according to n plus 1 rule, the value of the orbital which has higher value of n plus l will have the higher energy. So in between 2s and 2p will have higher energy, as we have already seen in the previous image also. Now in this case, in case of this 3s, the value of n will be 3 and the value of l is 0, because s subshell is there, so the value of l will be 0. Now the value of n plus l, 3 plus 0, it comes to be 3. Now what will we do when the value of n plus l becomes equal? Then at that time when the value of n plus l becomes equal, we have to check the principal quantum number value. The orbital which has less value of principal quantum number, that will be have lower energy. So among 3s and 2p will have lower energy. Since 2p in 2p principal quantum number n equal to has the lower energy than 3s, because according to n plus l rule, when the values of n plus l gets equal, so then we will choose that value as the lower, that orbital has the lower energy, which will have the lower value of principal quantum number. So here in 3s and 2p will have lower value of principal quantum number, that is 2. Now come to 3p. In 3p, n is 3 and l is 1 because p subshell is there. So the value of n plus 1 comes to be 4. In case of 4s here, fourth shell, if we come in fourth shell, n is equal 4 and l is equal 0 because s is there. So n plus l comes to be 4. Now what will, again the same value of n plus 1 n plus l comes. Now what will which orbital will have the lower value? The 3p orbital will have the lower value, because as the value of n plus l comes to be same, then we choose that value of energy as the lower value which has the low value of principal quantum number n. So here 3p will have lower energy because 3p will be equal to in 3p n will be equal to 3, which has lower energy as compared to 4s, and this can be more clear from the image which I have discussed previously. And also if we come to 3d, the value of n is 3, the value of l here it is 2 because d subshell is there, so value of l will be 2. 3 plus 2 comes to be 5. Now come to 4p. 4 is n equal 4 and l equal 1. 4 plus 1 again 5. So these two values have again these are coming to be the same value. So what will happen? Now here 3d will have lower energy as compared to 4p, because 3d orbital, in 3d orbital the shell number is 3 and in 4p orbital the shell number is 4. So we have to go to that that orbital which has lower energy, that will have the less value of principal quantum number. Now, so that's all for today. Now I have some questions for you, practice questions for you. Do these questions. So question first is, which orbital in each of the following pairs is lower in energy in a multi-electron atom? So from these 4 pairs, you have to calculate the orbital which has lower energy. Now question second, for each of the following pair of hydrogen orbitals, indicate which is higher in energy. Now from these pair you have to indicate which hydrogen orbital will have higher energy. Calculate the total number of radial and angular nodes present in 3p orbital. According to n plus 1 rule, which of the following orbitals has the highest energy? And these are 2 questions in which you have to find out which of the orbital will have highest energy according to n plus 1 rule. So do these questions and we will meet in our next video with our next topics. Thank you. Keep watching.